Multiple choice 13, the first three members of the alkanones are, and the full structural formula for each of these members are given. The general formula for the alkanones is, so we want to write the molecular formula for each of these members that are given. We want to stack the formula, and we always go with CnH2n to begin with. 3 times 2 is 6, 4 times 2 is 8, 5 times 2 is 10, and then we've got the oxygen on the end. So the correct answer to this is multiple choice answer B, CnH2nO. Multiple choice 14. Which of the following could be the formula mass of a cycloalkane? So we need to know that they have the general formula CnH2n. What we want to then do is we say, well, how many carbon atoms could we potentially have? So if I was to do the GFM of carbon, and that's 12 multiplied by 3, that gives me 36. I would want to do the hydrogens, which have a GFM of 1, but times it by 2 times the number of N that I've given in this case, which is 3, which would give me 6. 36 plus 6 gives me 42. So the correct answer to this is multiple choice answer B. This allows us to work out the key definition for metallic bonding. Metallic bonding is the electrostatic force of attraction between positive ions, which are formed from losing the outer electrons, and the delocalized electrons, and these are electrons that can move. We can see that we've got the diagram which represents a metallic bond. We can see the positive ions and the electrons which are able to move throughout the lattice structure. Multiple choice 16. Metals used to make aircraft have a density of less than 3 grams per centimetres to the -3, have to withstand temperatures up to 600 degrees Celsius. Which line in the table gives the correct data for a metal used to make aircraft? So the first part I'd look at is the density. The density has to be less than 3. So the only answers it could potentially be would be A or B, because these values are less than 3. We know that it has to withstand temperatures up to 600, which means the melting point has to be above 600. So the only answer that it could be for this would be multiple choice answer B. Multiple choice answer 17. Which of these metals can only be extracted from its ore by electrolysis and forms an oxide that is insoluble in water? So remember, acute zebra, Cant Macarena, aluminium and above. You would need to use the process of electrolysis to obtain that metal from its oxide. So the only potential answers at the moment could be aluminium or calcium. We then want to look up aluminium oxide in the data booklet using page 8, and we can see that aluminium oxide is insoluble, whereas calcium oxide is soluble. So the correct answer to this is multiple choice answer A, aluminium. Multiple choice 18. Which statement correctly describes the electron flow in the cell? So firstly, we need to know that it's electrons which flow through the wires. So the only potential answers that it could be is C or D, because the other two are talking about the electrolyte, which is our solution. We then have to look at the positions of the elements in the electrochemical series. We know that electrons flow from metals higher in the electrochemical series to metals lower in the electrochemical series. So therefore, the correct answer would be D, through the connecting wire from the aluminium to the nickel. Multiple choice 19. Which metal, when paired with magnesium in a cell, will produce the highest voltage? You may wish to use your data booklet to help you. We know that the bigger the gap, the bigger the voltage. So we're looking for magnesium combined with each of these elements. Whichever one has the bigger gap will produce the biggest voltage. So the correct answer to this is multiple choice answer B, lead. Multiple choice 20. The reactions occurring at each electrode are, and they're given for beaker A and beaker B. Which of the following equations is the overall redox reaction in the cell? You may wish to use the data booklet to help you. So when we're doing overall redox, we have to cancel out the electrons. Electrons cannot be present in the overall redox equation. So that means that multiple choice answer A cannot be correct, because we can see that both on the reactant and the product side we have our electrons. So if we're looking at beaker A and beaker B, they've got the same number of electrons, so we can cancel those out. And if we look at beaker A, we're reading it from left to right, we would have to have bromine in the liquid state, and so therefore the only correct answer could be multiple choice answer C, as B and D have the bromide ion on the reactant side, not the bromine liquids. Multiple choice 21. Polymethyl methacrylate is a polymer used in the manufacture of aircraft windows. A section of the polymer chain is shown below. The monomer used to make this polymer is... So every second carbon we want to cut it, and we want to draw out the repeating unit of our polymer chain, which I have put on the right hand side. What we have to know is this is the repeating unit where the bonds are open. Okay, so we have to make sure that the bonds are closed so that we have our monomer unit. So the only correct answers to this one at the moment, because our monomer's got to have a carbon to carbon double bond, would be A or B. We then have to look at the things that are at the top and are at the bottom. So we can see that on the top line we should have a CH3 and an H, and the only one that's got that with our bonds closed is multiple choice answer A. Multiple choice 22. Which line in the table is correct for the Ostwald process? So for this we want to remember our HIPPO. Haber uses an iron catalyst, platinum catalyst is used for the Ostwald process. So the correct answer to this could only be multiple choice answer B or D by looking at the catalyst. We have to know that the Ostwald process is for the production of nitric acid, and the formula for nitric acid is HNO3, so the correct answer to this is multiple choice answer B. Multiple choice 23. Radon-222 is a radioisotope present in the Earth's atmosphere. Plants can absorb radon-222 through their roots. Compared with radon-222 in the atmosphere, the half-life of the radon-222 in the plant cells will be. Now, this is rote learned. You need to know that the half-life of an isotope is a constant. It's unaffected by chemical or physical conditions, and it does not change. So the correct answer to this is multiple choice answer C, that the half-life will be the same. Multiple choice 24. A radioisotope is used to monitor blood flow around the body. In order to prevent damage to the body, the radiation emitted must be able to escape through the skin. Which line in the table describes the type of radiation emitted and the half-life that would make the radioisotope suitable for this use? So because the radiation is put in the body and we have to make sure that it can escape readily, it has to have a short half-life. So the correct answer to this could only be multiple choice answer C or D. But when we're looking at alpha radiation, this can be stopped by a few centimetres cubed of air or paper. So the correct answer to this has to be multiple choice answer C. Multiple choice 25. A student measured 25 centimetres cubed of sodium hydroxide for a titration experiment using a 100 centimetres cubed measuring cylinder. Their teacher suggested that there was a more accurate piece of apparatus to measure this volume. Which piece of apparatus should the student have used to more accurately measure out 25 centimetres volume of sodium hydroxide? Because the volume given is 25 centimetres cubed, and if we want it to be an accurate measure, we want to make sure that the piece of apparatus we use has the exact same volume. So the answer A and D cannot be correct because they have 100 centimetres cubed volume. In the text, it tells you that the student had already used a measuring cylinder, and the teacher said that there was a more accurate piece of apparatus, so the correct answer to this has to be multiple choice answer C, 25 centimetres cubed pipette.